Alright, ladies and gents, so what we're going to be doing today is we are going to first talk about a couple different things related to you guys studying and helping you guys to review so that hopefully in the future your test won't be so traumatic. So I'm going to give you guys one tool that I want you guys to do as part of your homework. So this is an assignment, so I will be checking it later. But before we do that, the first thing we need to address today is changing our table of contents. So this is the first video and the first discussion in our next unit, which is looking at energy. So how objects change and respond to their environment, right, by causing some kind of change. So that kind of thing that is shifting between different groups and materials. Okay, so alright, here I have a picture of our table of contents that I updated. So we have finished our unit that is on Newton's laws of motion, okay? So our page numbers are essentially now changed, right? So we ended our notes on page 13 for Newton's laws of motion, and now we are starting on page 14 with energy, okay? So you can do that and update it in your notebook, okay? So like I did up here, right? Our changes of our pages are from 8 to 13, and now we are starting page 14 of our notes. Okay, so you guys have that so you can make those changes. The other thing that we are going to look at is you guys should have got a sheet. Okay, so if you did not pick up this sheet, it's in the front of the room. On that sheet, you should have this image, right? So it looks like this, okay? And it's also going to come with this table, okay? So I put this table here. All right, so what this table is, if you zoom in, I glued it to the very front cover of my notebook, so I would like you to do the same. So on this, at the top of this table, it lists 3 things, 1 thing for each column. So for these 3 things, the first column you have is looking at an object's variable and the name. So we're essentially piecing apart our equation. So this is something that you guys should have been doing already, right? Learning what each of the variables correspond to. So what units you would expect to see when you're calculating something that's dealing with these, right? And what each of the letters mean that stands for various parts of these equations. So what I'm giving you guys is essentially a demonstration here of what kind of things I'm looking for on these types of questions, okay? So if we zoom in real close on our table here, I did 2 examples for you already, okay? So for each of these variables that you're seeing in these equations, you should be writing down what they mean, right? So you should see that, oh, I have an equation with the letter v in it. I know that v is equal to velocity, okay? I know that because v is equal to velocity, that its units would have to be meters per second, okay, or some distance divided by a time. Okay. Then I would record what equation I might want to use that for. So for example, if I want to find a velocity, I know the velocity is distance divided by time. So that sample equation is just to get you guys used to recognizing these things. So at this point in the semester, you should be doing this right away when you get a new equation. You should be looking at what variables are required for this equation and what units should I be looking for. Okay, this is why when we do our practice questions, guys, the first thing we do when we go through them is write down each thing that we do. Okay, we write down every variable. So what values do I have and what units are there and what does that correspond to? Okay, so this is something that I want you guys to do for every variable we've discussed up through now. So in your guys' notebooks, I want you guys to go through each page, each equation, and write down what things stand for. Okay, so like I did for acceleration, I know acceleration is equal to a. Okay, I know for acceleration, no matter what, I have a distance with a time, and that time is always squared. So if I have an acceleration, I should have a distance divided by a time squared. Okay, so meters per second squared. And then I know my equation to calculate acceleration, one of those is delta v over t, right? So change in velocity divided by time. Another one I could have put there is F equals ma, that the force of an object is equal to the mass and its acceleration. Okay, so this table that you guys have shouldn't be totally full because we haven't gone over all of the variables yet that we're going to be addressing, but it should be pretty full, and I will be checking this next time I see you guys in class. Okay, so this is part of your assignment after you watch the lecture video, is to go through each page of here, every equation we've learned up through now, and record that information in this table. Okay. All right, so let's go after you guys have done that. So do that after you watch this lecture video. But what I want to do now is I want to go in and we're going to start talking about energy. So we're going to begin our next unit looking at energy. So again, I've What I did here is I went ahead and took a picture of the notes that we're going to go through. So I'm going to discuss all of these things with you like we do in class. Okay, you guys should follow along and write down everything on this list so that you have those notes pages in your book. Okay, so we are starting on page 15, right? We'll add something to page 14 a little bit later, and I'll show you what that is at the end of the video. Okay. All right, so what we're going to be looking at is essentially energy, right? We're going to be looking at what energy is, how energy interacts and how deals with objects as they're moving or changing position or dealing with chemical heat, all kinds of stuff. Okay, so we're going to begin there. But before we can really talk about energy, we've got to learn about what energy is and the nature of energy, so how it interacts with itself and what kinds of energies objects can contain. Okay? So the question that we first want to start asking ourselves is, as we go through our lecture, we want to figure out what's the difference between potential energy and kinetic energy in objects. Okay? All right, so the basic definition of energy that we're going to be using in this class is that energy is essentially the ability to cause a change, okay? So if something is causing an object to change its position, right, if it's displacing the object, so moving it from point A to point B, if it's causing the object to accelerate, if it's causing an object to fall, all of those things are energy, right? They're just the ability to cause an object to change, okay? So we have examples of energy that we're going to look at throughout the semester, right? We have electric energy, right? Something that you guys are all used to because you're all probably charging your Chromebooks right now when they should be charged. So you're charging your Chromebooks, you're using electrical energy. That electrical energy is being stored in your battery, and then it's released so that it can cause change, right? It can cause the pixels to change color on your sheet as I talk at you, right? It's causing energy to come through your line out so that you hear the audio. So it's causing mechanical change in the speakers that you're listening to me to. So again, that energy is causing all of these different things to happen. You have chemical energy, so you're digesting your breakfast or digesting your lunch, right? That chemical energy that's stored in that food, you're using it so that you can survive, right? Thermal energy, right? Something that you're all losing because my classroom is probably super, super cold right now as usual, okay? Because these are, again, all things that cause change, okay? So, again, these changes are going to be likely to correspond with some kind of response or some kind of reaction, right? So that's one thing you can look for when you're looking at whether or not energy is present in a system. Is there a response? Is an object changing? All right, is there a reaction to an input? Okay, so for example, like movement, right? If I take something like this pen, right, and I drop it, right, that means that that pen is experiencing movement. So there was energy involved in this pen falling, okay? So because there was some kind of change. Okay, so with motion of objects, that's kind of where we're going to start because we've just finished talking about all of Newton's laws of motion, right, and what those mean for our movement and how energy is going to change how an object responds. Okay? So motion is directly linked to the energy that's contained within an object and what is released from that object, okay? And we'll talk about that as we address like more specific forms of energy. But today we're just going to focus on energy related to motion, okay? So we're good at motion. We know that objects can change position, right? Because say they experience a force and that force is pushing it so many newtons to the left or the right or falling and pulling it down because of gravity. Okay, we know that is something that can cause an object to change. All right, so let's talk about the broad forms of energy. Okay, you guys have probably heard of these two things before. You've probably heard of kinetic energy and potential energy. And so in physics, those two things are kind of broad categories of motion energy, right? Energy that's related to motion. Okay? So if we say something has kinetic energy, that means that that thing is exhibiting energy in the form of motion, that it is changing. Okay? And so an object is going to contain kinetic energy if it's moving. That's the only way it can have kinetic energy, is that it's experiencing, that it's changing a distance over a period of time. Okay? So in order for an object to experience kinetic energy, it has to be moving. Okay? It has to be going from one place to another. So energy in the form of motion can be linked to two things that an object will always have, right, if it has kinetic energy. An object will have a mass, again, the amount of matter that's contained within that object, but then the object will also be having a velocity, so the object will be moving. Okay, so you can think about it this way. We've already looked at objects that have kinetic energy, okay, and we looked at that using an equation, P equals m times v. Okay, so an object that has momentum is an object that has kinetic energy. Okay, so we saw that when we saw things collide, right? When those two objects hit each other and released and bounced back, right? We were seeing a change, right? Those objects changed position. So when they hit and collided, they had an initial velocity and an initial mass. Once they collided and then bounced back or stuck together, those objects had a change in those. It had a change in mass or a change in velocity. Okay, energy was conserved in those elastic collisions, right? Because the energy before was the same as the energy after. Okay, but the mass and velocity changed. So kinetic energy is directly related to an object's momentum. Okay, so we'll learn how to calculate kinetic energy in our next lecture video. But right now we are in our next lecture. But we are not going to do that today. Okay, but you should know that there is a direct correspondence of kinetic energy to momentum. Okay, they're not separate. So an example of a type of motion you might experience is like what I drew over here, right? Like if you have an individual who is going down a slide, right? They started a starting position, they're going down the slide, accelerating, right? Changing their position from the start, and that's traveling over a period of time. That's kinetic energy. So you sliding down a slide, you are experiencing kinetic energy. So I shake my head left and right, that's kinetic energy because I'm moving, right? If I raise my arm up and down, I'm releasing kinetic energy. Okay? All right. So if you are moving, right, the opposite of moving is not moving, right? So kinetic energy is the energy of motion. Well, there is a type of energy that objects contain even if they aren't moving, okay? So we call that energy potential energy, right? It's the energy that's stored, right? Another way to think about it is the object has the potential to move, right? It has the potential to change its position, right? It's in an area where it could roll, it's in an area where it could fall, it's an area where it could slide, it's an area where it could drop. Okay, if it has those possibilities, that means it has potential energy. And so not only related to motion, you have different types of potential energy that we're going to talk about. But when we talk about potential motion, just know that there's an ability for that thing to possibly change, okay? That there's something about it that can be altered. It can release kinetic energy somehow, right? Just by changing position or changing some other reaction, okay? So, like in my example of someone sliding down a slide, if you are experiencing potential energy, you're sitting on top of the slide. Okay, that's what it means, right? You're sitting there waiting to change, you're just hanging out. You're deciding like, oh, do I want to go down the slide? I don't know, but maybe I do. Sure, whatever. Once you decide, then you can go down and you're experiencing a change in energy. So you change that potential of being able to go down the slide, right, to actually going, which is kinetic. Okay. So there are different types of potential energy that you are going to see and we are going to talk about throughout the semester. Okay, one of those types is called elastic potential energy. Okay, so an object that is stretchable or movable, right, is going to store kinetic energy. So I don't have a rubber band with me or a slinky or something like that. But you guys have probably seen this before. If you have a rubber band, right, you can pull on that rubber band, right? And you can hold that rubber band and you can feel that it has tension, right? Because you know what happens when someone releases that rubber band. What is that rubber band going to do? It's going to snap back, right? It's going to turn back to its original position. Or if you've taken that, right, someone's pulled it and then let go and it releases right back on your skin and it hurts like crazy. Okay, that is an example of changing from that potential energy that was stored in that stretchy latex fabric or latex material of a rubber band as it released, right, it snapped back and hit. Or if you take a rubber band, right, shoot it and release it, okay, and it shoots across the room, that's again because you have potential energy that's stored in that pull. Okay. Another place where you're going to see chemical energy or potential energy stored is within chemicals. So chemical potential energy is energy that's stored in chemical bonds of materials. So like your food that you're digesting right now, you are getting energy from that because you are digesting it and breaking down the chemical bonds between different atoms in that structure. Okay, so you have material that's there, you're breaking it up into smaller pieces, and you're releasing it and you're using it in a different form, okay? So it has the potential to cause change, right? If you didn't eat something right, you guys get lethargic and tired, and you don't have the energy necessary to do the motions that are required of you, right? That's whether that's like doing dancing or doing PE or just sitting and thinking about the material that you're being taught in a lot of your classes. So again, the energy that's stored within food, chemicals like wood and stuff that you burn, right? It changes, it reacts, it causes something to be released. It's a potential energy. Okay. right? And then the last type of potential energy that you might see is called gravitational potential energy. So gravitational potential energy is anything that could fall, right? If something has the ability to fall from a high place to a low place, it has potential energy, okay? So you see this like when you look at a waterfall, right? The water on top of that waterfall has potential energy. As it goes over the ledge and gravity pulls it down, it is going to be carrying that energy, right? And that energy is being stored just based on how far it drops, right? Things that are falling further are going to have much more potential energy than things that fall very shortly, right? So like you can listen to this. So like if I drop this and let it go, right, it doesn't bounce back very much, right? So if I drop it from like the very bottom down here, so it's not very far, maybe like 6 inches, right? But if I drop it up higher, right, it's probably going to, right? You saw that it slightly bounced back, right? Okay, it's because that object has more stored gravitational potential energy as I raise it up. Okay, once I let go of it, right, it's going to release more kinetic energy, right? As I drop it, it changes that potential energy into kinetic energy. Okay, and so we'll talk about the transition to and from, but today the thing that you really need to walk away from is knowing that energy has the ability to cause change, right? That these different forms of energy are all essentially altering the state of something. Okay? Right? You should know that motion is linked to energy, like we've seen, right? And that the difference between kinetic and potential energy is that kinetic energy, an object is moving, and potential energy is the objects or the chemical or whatever it is, the energy that's stored inside of something. Okay? So what you guys have to do after we did our notes is I want you guys to get out your paper that you had. Okay, so the paper that you guys have has images like this, right? Ones that are showing different types of chemical energy. Okay, so these images right here, right, represent examples of the different types of energy that are on here. Okay, so these types of energy don't correspond next to each other. This is the stuff that you want to be able to identify based on the name that you are given of each of the different individuals' types of potential and kinetic energy. So what you guys are going to do is, into your notebooks, there is on page 14, I want you guys to get a half sheet of construction paper. So this half sheet of construction paper you can share with someone sitting next to you. What you're going to do is you're going to take it and you're going to cut it in half, right? So you're going to take that paper and you're going to fold it hamburger style, right? You're going to then take that paper and cut it down the edge so that you have two halves of that paper. Then what you're going to do is you're going to take that paper and you are going to fold it in half again so that you're left with a tall kind of hot dog shaped piece of paper. Okay. So what you'll do next is on that piece of paper, I want you guys to cut it so that there are 5 flaps. So you're going to make 4 cuts to leave you 5 flaps. And those flaps should be big enough so that your pieces here, when you cut them out, will fit on your sheet. What you are doing with these 2 pieces of paper is you are essentially quizzing yourself on the vocab that we went over in our lecture video today. Okay, so for the different types of potential and kinetic energy, I want you to identify which image best corresponds with the type of kinetic energy or potential energy that's listed here. So which of these is related to this? Okay, so for example, I will give you one of them. If I look at my list here, okay, one of the things I have is this cookie. Okay, this cookie is food. So which of these types of things do you think is going to be stored or released in that cookie? Chances are that thing will be molecules that we digest, right? Because we have chemical potential energy stored in that cookie. Okay, so I want you guys to go through those things and I want you to fill this out and make sure that's there. Okay, so when you guys are done with that, okay, you guys have a couple questions I want you to answer on a separate sheet of paper. Those questions are linked below this file. Okay, so on Canvas, if you look below it, it says questions for September 21st. Okay, so answer those questions there. Okay, on a separate sheet of paper. You will turn this paper into me on Monday. Okay. So again, if you have questions, feel free to email me and ask me those questions related to this stuff, and I will be happy to help you. Okay. So again, if you guys have any other stuff that you want to address or talk about, please let me know, and I'll be happy to answer those. Okay. All right. So go back through front of your notebook, fill out this table. Okay. Make sure that you list all of the variables, right? The letter that corresponds with that variable, all of the units, right? And example equations that include those things. Okay. All right. So, good luck.